Hello, everyone. Welcome to Cyber Talks, where we delve deep into the vast world of cybersecurity, starting from its inception to why it's important in our day to day lives and how you too can start your journey in cybersecurity. Today, we'll be delving into a basic overview of the OSI model, an essential framework for data transmission in the digital world. We'll explore all 7 layers, starting from the physical layer to the application layer. But before we get into each layer, we must understand why the OSI model is so widely used.
At its simplest, the OSI layers can be defined as the overarching framework for how a computer system can communicate with each other. More specifically, it is the process by which data is given the information to be transferred over a computer network. Now that we have a basic understanding of the OSI model, let's look at each layer individually and their role in network communication.
First, let's head into the lowest layer of the OSI model, the physical layer. At its core, the physical layer carries data across the wire by having a physical connection between devices. These pieces of data are defined as bits, or ones and zeros that are transferred across a physical medium, such as Ethernet cabling or Wi-Fi. These bits represent encoded data that will be transported to the user.
Next, let's delve into the second layer of the OSI model, the data link layer. This layer is responsible for transmitting and receiving frames in conjunction with the physical layer. It accomplishes this through a direct connection between the physical medium that transports bits, the ones and zeros that contain data, and the network interface card, or NIC, of both network devices. The NIC serves as the bridge for the transmission of frames, which are the standard form that data takes in the data link layer between network devices. Each NIC is assigned a unique identifier known as a MAC address, which enables one network device to know where to send data to another.
When a frame is sent, it contains both the source and destination MAC address that guides data transmission. Data is transmitted through a medium that allows 2 network devices to communicate within a network. Each time a frame interacts with a layer 2 network device, it performs a hop-to-hop delivery of data from one NIC to another. This means that layer 2 data transmission may necessitate multiple hops before reaching its destination network device.
However, you might wonder how end-to-end delivery is ensured if layer 2 devices utilize hop-to-hop delivery. To perform that, we need the network layer, which is the third OSI layer. The network layer provides end-to-end delivery of packets from one network device to the other. However, how does it identify which device it ends at? Well, layer 2 devices utilize MAC addresses, so layer 3 network devices utilize IP addresses. This is done through mediums such as routers, which are layer 3 devices and ensure end-to-end transmission. Additionally, layer 3 protocols coordinate with layer 2 protocols for delivery. This can be seen in this simulation, where we have a layer 2 header representing the source and destination MAC address for each NIC at each hop. However, you can see that while the MAC address is changing for each hop, the source and destination IP address remain the same from one end to the other, highlighting the network layer's end-to-end delivery to reach the final device.
Next, let's dive into the fourth layer of the OSI model, the transport layer. The transport layer's fundamental functionality lies in its service-to-service communication. For example, say I'm on my phone and I was trying to run a streaming service, a game, or a music platform like Spotify. To go even further, maybe I'd want to run all these services at the same time. These services fundamentally work by sending data through the wire with the layer 2 and layer 3 header and allocating each pace of data to one service. However, how do I know which data to allocate to which service? This is where the transport layer comes into play. It works by allocating the right data to the right service. It does this by implementing a port-to-port addressing scheme. These ports work under 2 subsections, one for TCP and one for UDP.
To understand why these ports are split up like this, we must understand what TCP and UDP are. Simply, they're strategies to help identify and allocate data to each service. TCP works by implementing a 3-way handshake, which ensures reliability and retransmission, whereas UDP offers great efficiency at the expense of one-time transmission. TCP works better for services that favor reliability, such as message transmission, and UDP works better for services that require quick transmissions, such as video and audio services.
Finally, let's delve into the application layer in the OSI model, which is responsible for providing network services and interfaces directly to user applications. It enables communication between different applications running on separate devices by defining protocols and standards for data exchange. This layer deals with data formatting, ensuring that information is properly structured for transmission and interpretation by the receiving application. It includes a wide range of protocols such as HTTP for web browsing, SMTP for email, and FTP for file transfer, each serving specific application level functions. The application layer also manages communication sessions, establishing, managing, and terminating connections between applications as needed. Overall, it acts as an interface between the user and the underlying network infrastructure and facilitates seamless communication.
Through the implementation of these 7 layers working together, the process of data transmission is achieved. This is done through an overarching process called encapsulation that starts with data in the application layer, which is packaged with layers 2, 3, and 4 headers, and finally transmitted as bits along the wire until it reaches the network device. When it reaches the end device removes all the headers, revealing the data underneath. This is called de-encapsulating. And this framework allows for data to be most efficiently and securely transmitted to a user, allowing for communication between multiple network devices.
Well, that was a basic overview of the OSI layers. Thank you for listening to Cyber Talks, and we hope you found this video useful. For more information, make sure to visit our website and tune in for more episodes to stay safe in the vast world of cybersecurity.